Okay, so today we are starting a new unit over circles. So we're just going to go over several different vocabulary words for circles, and we're going to create our dictionary. So our first term is circle, of course. So our definition is going to be the set of points equidistant from a given point, which is the center. Okay, so we have an example here drawn for us, and we are going to name this circle P. So in our definition, our circle is the set of all of the points that are equidistant from a given point, which is the center. So every point on this circle that we could possibly draw is going to be the same distance to the center point P. So we call this circle P, since the radius is the center is point P. Okay, so our next term, make sure you have that written. Our next term is radius. So a radius is a segment with endpoints at the center and on the circle. Okay, so you know what a radius is. You've heard of this term before, but let's go ahead and refresh our memory. So say this circle again is circle P. In order to draw a radius, we can put a point anywhere on the edge of the circle. I'm just going to draw it here. I'm going to name this point A, and I'm going to connect the two. I'm going to create a segment there. So this segment right here is our radius. So I'm just going to write AP. Remember, it has a bar over the top of it with nothing but a straight line, because this is just a segment. So that's our example there. Okay, so the next definition that we're going to look at is a chord. Okay, so a chord is a segment with endpoints on the circle. So both of the endpoints of a chord are on the circle. So let's draw 2 points somewhere on this circle here. Doesn't matter where. So I'm going to draw this first point. I'm going to name it A. I'm going to draw my next point. I'm going to name it B. And I'm going to connect those 2 points. So if I connect those 2 points, what I'm creating is a chord. Okay. So 2 of the endpoints are on the circle. So my chord in this picture is segment AB. Okay, next is a familiar definition, diameter. You've seen this before. So the technical definition is a chord that passes through the center. So remember that the diameter is equal to 2 times the radius. It's twice as long. Okay, so a diameter is technically a chord because the endpoints are going to be on the circle. So let's start out by drawing the center of our circle. I'm going to name it P. And then let's draw two endpoints. I want it to go straight through the center. So I'm going to put it here and here. And I'm going to name them A and B. And I'm going to draw a line that goes straight through. Okay? So my diameter here is segment AB. Okay. Okay. Next definition is secant. Okay, so a secant line is a line that intersects the circle in exactly two places. Okay, so it's a line this time, not a segment. So it's going to intersect the circle in exactly two places. So I'm going to draw 2 points somewhere on the circle where it's going to intersect. I'm going to call them E and F this time. So I'm going to take a line and I'm going to make it pass through both of those points. So something like this. This is a secant line because it touches the circle twice. So my example here is line EF. So it has a bar over it with 2 arrows because it is a line. Alright, our next definition is a tangent line. So a tangent is a line that intersects the circle at exactly one place. Okay, so it only touches the circle one time. So you're only going to have one point on your circle that this line touches. So let's pick that point. I'm going to place it right here. I'm going to call it X. So I know that this line is going to go through this point, but it can only touch the circle once. So this line can't be drawn this way, because if it did, it would touch the circle twice. Can't be drawn this way, it would touch the circle twice. So I'm going to draw it something like this, where it only will touch that point one time. But as we know, a line has to have at least 2 points. So let's create another one. I'm going to call it Y. So this example is line XY. Okay, our next definition is point of tangency. So the point of tangency is the point at which the tangent line intersects the circle. So this is where the tangent line touches the circle. So let's draw another tangent line just to get even more familiar with it. I'm going to draw my point where the tangent line touches first. So I'm going to draw that tangent line through this point, and I'm going to name that point C. So my line is going to look something like this so that it only touches the circle once. I'm going to create another point though. Lines have to have at least 2 points. I'm going to call that D. So in this picture, if I'm trying to figure out what the point of tangent C is, I'm looking for the point where this line touches the circle. So where it intersects the circle, the point is point C. So that's my example there. Okay, I'm going to give you a minute just in case you need to catch up writing. All right, go on to the next page, flip it over. Okay, the next thing that we are going to talk about is our central angles. So we're going to have some angles within these circles. First one we're going to talk about is central angle. So the central angle is going to be an angle with a vertex at the center and 2 sides that are radii, which is the plural of radius. So I'm going to have my center point here. I'm going to call it point B. Now it says that this is going to be my vertex and my 2 sides are going to be both radii. So I'm going to create 2 radii. So I'm going to create one here. I'm going to call this point A and I'm going to connect it to the center point. I just created a radius. Now I've got to create another one because both the sides are radius. So I'm going to create another radius. I'm going to make this point C. I'm going to connect it to the center. So I just made 2 sides here, 2 sides. And those 2 sides form an angle here at the center. That's why it's called a central angle. Right here, this angle is a central angle because its vertex is located at the center and the 2 sides are both radii. So this is my angle, angle ABC. That's a central angle. It's located at the center of the circle. Okay. So the next angle that we're going to talk about is an inscribed angle. So an inscribed angle is an angle with a vertex on the circle and 2 sides that are chords. Okay, so this time we are going to start with this vertex. I'm going to make this a vertex here. I'm going to call it F. And I'm going to create sides that are chords. So they're going to be somewhere else along the edge of the circle. So I'm going to make the first side here. I'm going to call this one E. And I'm going to connect it to make the first chord as one of its sides. I'm going to create another chord. I'm going to call it G. Connect it to make another of its sides. I just created another chord. And what I just created here is an angle that's located on the edge of the circle. That's called an inscribed angle. So this angle is angle EFG. Alright, next one we're going to talk about is an arc. Okay, so an arc is a portion of the edge of the circle defined by two endpoints. Okay, there's a symbol for this. The symbol for an arc looks like an arc, really. Just this little curved line. And it's going to go over the letters that signify the endpoints. So we're going to create two endpoints on our circle. It doesn't matter where. So I'm going to create one here. I'm going to call it C. I'm going to create one here. I'm going to call it D. Okay. So this portion that I just created that goes around the edge of the circle, it's called an arc. Okay, it's actually part of the circle's circumference. So my arc here is going to be named CD with that little symbol over the top of it to signify that it's an arc that I'm talking about. Okay, we have three different types of arcs. We have a minor arc, we have a major arc, and we have a semicircle. So let's look at a minor arc. So a minor arc is an arc with a measure less than 180 degrees. Okay. When it's a minor arc, you only use two letters to name it. So use two letters to name it. That's very important. So we only use two letters to name this one because it did not go over halfway around the circle. Didn't go over 180 degrees. So remember, half of a circle is 180 degrees. So we got to make this arc less than half of the circle. So we're going to make a minor arc. I'm going to call this one E. I'm going to call this one F. I'm going to connect them. I'm going to show which part of the circle this arc makes up. It's less than 180 degrees. So this minor arc is arc EF. Okay, next we're going to look at a major arc. So it is an arc with a measure greater than 180 degrees. So with a major arc, when it's more than 180 degrees, you have to use three letters to name it. Okay, so if it has two letters, it's going to be less than 180 degrees. If it has three letters, it's going to be more than 180 degrees. So let's create 3 points somewhere on the circle. I'm going to call them X, Y, and Z. And I'm going to connect them X to Y and Y to Z. Now this arc, it takes up, goes more than 180 degrees around the circle. Okay, so we would call this arc X, Y, Z with that symbol over the top of it to signify that it is greater than 180 degrees. It is a major arc. Okay, last definition, we are going to talk about a semicircle. So a semicircle is an arc with endpoints on the diameter. It is always going to equal 180 degrees. Okay? Because it's half of the circle. So if I create a diameter here with the endpoints here, I'm going to call them A and C. So this arc here would be half of my circle. And I'm going to create another point here. I'm going to call it B. So this arc, this is a semicircle because it only takes up half of the circle. So this arc is called arc A, B, C. This is my semicircle. Its endpoints are on the diameter. It is going to be labeled with 3 letters as well. Okay, you have some formulas that you need to remember. You've seen these formulas before. At least you've seen area and circumference. Arc length will be a new one. So our area formula for a circle is area equals pi times radius squared. Remember, R stands for radius. Write it down if you don't remember. Okay, circumference, you have 2 different formulas that you can use. Circumference equals 2 pi r, where r is your radius. Or you can use pi times diameter, where d is your diameter. Depending on your question, you will find which one is easier to use. If your question gives you things in terms of radius, use 2 pi r. If it gives you the values in terms of diameter, use pi times diameter. And then a new one, arc length. I'm going to use a cursive L, just so that it doesn't look like a 1. Arc length is going to equal x times c divided by 360. So x stands for the degree of the arc, and c stands for the circumference. We're going to talk about this formula later. We're going to use this formula quite a bit, and it's really not too bad. Okay, give you a few minutes to write all of that down. Make sure you have it written. Okay, go on to the next page. The next page at the top says name that circle part. I'm going to do a couple with you, and then I want you to do the rest on your own. So the directions read, use the diagram below along with the bank to classify each circle part. Parts may be used more than once. So don't mark them out once you're done with them, because you may use them more than once. So what you're going to do, zoom out a little bit. You're going to look at the question and then reference the picture and see what it is that that segment or line is. So number 1 tells us to look at LQ, this segment, LQ. So this segment, if you look, it only touches the circle 1 time. So the definition of this right here, the definition that would match that segment, a segment that touches the circle only 1 time, would be tangent. Okay, I'm only going to work a couple with you. So number 2, look at the segment WY. So WY here. touches the circle twice, but it doesn't keep going, it's not a line. Touches it twice, it has the endpoints on the circle, so that definition would be chord. Okay. Number 3, it's an angle, so it's either going to be a central angle or an inscribed angle. Those are our only two choices. So let's look. If it sits on the circle, it's an inscribed angle. If it sits at the center of the circle, it is going to be a central angle. So let's look. So I have angle NQR. So this angle right here. That angle is on the edge of the circle, so that is an inscribed angle. Okay, and the number 4, X. That point at the center of the circle is the center. Okay, so I'm going to let you finish up the rest of them. When you're finished with this page, I want you to write your name at the top, and I want you to turn it in. It is a grade. So make sure you are quietly working on this page.